Hi everybody. Today we're going to be talking about the distributive property of multiplication along with combining like terms and algebraic expressions and equations. The distributive property is one of those fundamental knowledge benchmarks that you need to know before heading on to algebra. It'll help you in the long run. So before we can start, let's talk about what distribute means. Distribute, some synonyms in the dictionary are disperse, to give, disseminate, divvy up, dish out, share, etc. Just means you have to do it evenly and equally. So why is this so important? It makes mental math easier, and it also enables you to do algebra. It's a fundamental property, it's a foundation of algebra, so without this skill, you will probably not do very well in algebra coming up. So, mental math example. So using your eyes and your brain, you should be able to do these without a calculator. So I'm going to teach you how to do mental math using the distributive property of multiplication. So if you had a math fact like this, 5 times 499, first thing you look at, you're like, I'm shutting down. I'm not doing that. It's way too hard. The distributive property makes it much easier to do mental math. You can rewrite 499 as the quantity of 500 minus 1. It makes it much easier because then when you take 5 times 500, you could do 5 times 5 in your head to get 25. And then you add on your 2 zeros, 2,500. Subtract 5 times 1. 5 times 1 is 5, and 2,500 minus 5 is 2,495. 2,495 would be your answer. And you'd be able to do that either with a few scratches on your paper or in your head. So here's another mental math example. You can separate 307 times 9. You could do this many different ways. I think the easiest way to do this is to break 307 down into something that is easier. So I'm going to change 307 into a different quantity. You can do 300 plus 7 as one example. So 300 plus 7 times 9. The distributive property says you have to distribute everything on the outside times the inside. So 9 times 300 is 2,700. And 9 times 7, you can use those finger skills of 9. 9 times 7 is 63. So my final answer is 2,763. Very quick on pencil and paper or using mental math in your head. You can do it a lot faster than taking 307 times 9 using long multiplication. Much faster, and it's accurate. So how will you use the distributive property in algebra? It's not alien. This is a picture of a spaceship. Using variables, you're going to need to recall the rules for multiplying and dividing integers. You have to know those. So a positive times a positive is positive. A negative times a negative is also positive. A positive divided by a positive is positive, and a negative divided by a negative is positive. Whenever they're the same, your answer or your outlook is good. So if you have people that are positive going on dates, they're going to have a good time. If they're the same type of personality, all good. You run into the negatives when you multiply the opposites or divide the opposites. When you divide the opposites, your answer is going to be always a negative answer. You have to know that before continuing on using the distributive property to get the correct answers. So we're going to write this example down. You have a piece of paper, just write it on the back, please, with your blue sheet. 4 times 3x minus 5 minus 2. So I'm going to write this down. Pause until you have it done. And now we're going to distribute. So you draw an arrow. You're going to multiply everything on the inside by whatever's on the outside. So 4 times 3x. You take the coefficient and multiply 4 times 3, and you get 12. Your variable stays the same, so 12x. 4 times, and this is the important part, it's 4 times a negative 5. 4 times a negative 5 is negative 20. And then on the end, I have minus 2. Now I want to see if I can combine any like terms. I have just a plain old number. I have a constant and another constant. So I can combine my constants. Negative 20 and negative 2 is the same as negative 22. So my answer is 12x minus 22. I want to double check that it's written in standard form. Standard form, again, is the exponent with the highest power, variables alphabetically, and plain numbers are constants on the end. I can't go any further. It's simplified because these are not like terms. So my final answer is right there. Standard form. Let's try another one. So write this down and then pause, please. All right, let's get started here. We have to first find the coefficient that's out in front. There's a negative sign, but from the other day, you know, when there's no number, you have to slide in that 1. So this is the same as a negative 1. What's negative 1 times x? You should say, well, that's negative 1x. What's negative 1 times a positive 7? The signs are different, so your answer is going to be negative. Negative 1 times a positive 7 gets you negative 7. Now I have a negative 2 multiplied by everything on the inside. Negative 2 times 3 gets you a negative 6x. A negative 2 times a negative 5. A negative times a negative is a positive. So positive 10. From here, I want to look to see if I have anything that is alike. So now to write this in standard form, I'm going to take my variables and put them first. I have negative 1x and another negative 6x. In all, I have negative 7x. Then I can combine my constants, negative 7 plus 10. Different signs subtract, so I have 10 minus 7 gets you a positive 3, because I keep the sign of the bigger one. So my answer is negative 7x plus 3. That is as far as I can go. I've used the distributive property. As far as I can go, I cannot combine those because they're not like terms. Please pause the video and write this problem down. I have a negative 3 times a positive x. I get a negative 3x. Now this next one, I take the negative 3 and multiply it by a negative 1. A negative 3 times a negative 1 gets you a positive 3. So I write plus 3. So I've distributed this negative 3 to everything inside my parentheses, and now I have to work over here. I have a positive 4, and I have to distribute that times everything inside the next parentheses. Positive 4 times a negative 1x gets you a negative 4x, and a positive 4 times a negative 7 gets you a negative 28. Pause the video and see if you can combine like terms before checking your answer. So I could combine my negative 3x and my negative 4x because they're both the same variable with the same exponent. So I have negative 3 plus negative 4 gets you negative 7. And then I have the constants of 3 and negative 28. I can combine them because they're just plain numbers. Negative 28 and 3 gets you a difference of negative 25. So I have negative 7x minus 25. It's written in standard form because my variables come first and my constants are at the end. I can go to the next problem. Simple, little bit simpler here. I have a negative 5 times 2x and a negative 5 times a negative 3. Pause and see if you can work this out on your own. If you got this answer, you're not right. Neither am I. I made a mistake. I didn't finish this problem. A negative 5 times a positive 2 is negative 10x. And a negative 5 times a negative 3 is a positive 15. I wrote down the 15, but this is one of the most common mistakes. I forgot my plus or minus sign. So the key thing here is when you say your number, positive 15, you write the positive sign. If you say negative, you put a minus sign. So the final answer is negative 10x plus 15. It's written in standard form because my variables come before my constants. This next problem has 3 terms on the inside. Please don't let that scare you. Pause the video and work it out. When you take a negative 6 times a negative 3, you get a positive 18b. A negative 6 times a negative 1c gets you a positive 6c. And a negative 6 times a positive 7 gets you a negative 42. I can't combine the b's and c's because they're different letters, and I can't combine the negative 42 with anything because it's a constant, and everything else is a term with a variable. You're done. You may also see problems like this. You might see the number on the outside, on the right side, instead of the left. So this means the exact same thing. If you'd like to rewrite it, you can. Otherwise, you just distribute from the back end. And since you have to write it in standard form, I always look to the one that has the variable or the highest exponent first. So I do 2 times a negative 8x to get a negative 16x, and then a 2 times a 9 to get a positive 18. So that's simplified, and it's written in standard form. You might also see it like this. This number here is a negative 1. So this negative 1 needs to be distributed on everything on the inside. I'm going to do them in alphabetical order. B comes first. So I do negative 1 times 3b, I get negative 3b. And then I'm going to do my c. Negative 1 times 2c gets you a negative 2c. And then finally my constant. A negative 1 times a negative 7 gets you a positive 7. Now technically you could work either way and then rearrange them at the end. I could do just from left to right here. I got a negative 3b plus 7 minus 2c, and then go ahead and rewrite it in standard form. You'll get the exact same answer at the end. I just like doing it in alphabetical order already because that's one less step I have to do. Recap. Distributive property means you need to share everything on the outside times everything on the inside using addition or subtraction. Distribute, share and care, my friends. The blue sheet on the other side, the distributive property practice, is for what you to work on in teams right now. Be careful, ask questions, try your best, and there are 16 problems, so 16 points. Self-correct when you're done. And thanks for being here. I appreciate it. Bye.